So 6.2b today. Example 1 is the integral from 0 to 1 of x cubed plus 7 squared times 3x squared dx. So what do you think about this problem? How should we start, do you think? That's good. It is a U substitution problem. How did you know that, Madison?
I guess.
Fair enough.
I saw the function inside of another.
Yeah, you didn't totally guess. You need to give yourself more credit than that. You have it. She's saying there's x cubed plus 7 being squared, right? So there's a function inside of another function, which would lead us to believe that it's chain rule, but it's an integral, so it's backwards chain rule, so it's U substitution. Okay, so that's correct. It is U substitution. Now, what is different about this U substitution as opposed to the other U substitution problems that we've seen? Yeah. Sometimes chain rule, backwards chain rule is going to be two things multiplied, right? So it's sort of just chain rule because of that. I see what you're saying, but the result of a chain rule derivative is that there's a multiplication at the end. So really it's just chain rule. But you're right, there is a backwards product rule, and that's that you have, but this is not that. So what are you thinking? It's a definite integral. Now he's using a fancy term. What is a definite integral? It's when you're finding area, right? It's when there's numbers here and here, right? If there aren't numbers, then it's an indefinite integral, and then you just take the antiderivative and you get a plus c. But when there are numbers, the final answer is going to be an area. And so this is why this is different. But it's still a U substitution, like Madison said. And she's said that the x cubed plus 7 was inside the square, right? So that's what the U is. Generally, the U is the function that's inside of another function. So since x cubed plus 7 is getting squared, that's why we're setting U equal to x cubed plus 7. So then you take the differential. And then you divide by 3x squared to get the dx by itself. Then you go back to the original problem and you translate it into U's. It's in x's right now. We're going to translate it into U's. So this is U squared. The 3x squared is still there. Then I have dx, but I'm going to replace dx with all of this. So then that's nice because the 3x squareds are canceling. So my U substitution was successful because now I've got an easier antiderivative. Okay, now I am not putting 0 and 1 here on purpose. So if you accidentally put a 0 and a 1 there, please erase them because those are not correct. Because when you translate to du, these numbers need to be U values. And 0 and 1 are x's. So we have to translate these as well. The way you translate is right here. This tells you how to find a U if you know an x. So if x is 0, just put a 0 in for x, and then I can find out that U should be 7. So x equals 0 corresponds to U being 7. So that means this bottom number should be a 7. And then x equals 1 corresponds to u being 8. So that top number should be an 8. Okay, so now we're ready to take the antiderivative. The antiderivative of that is u to the third over 3. And we're going to figure that out from 7 to 8. Then you plug in 8, and you plug in 7, and you subtract. So it's 8 to the third over 3 minus 7 to the third over 3. The nice thing about this, we never have to translate back to x's. We can just figure out the final answer without translating back. 8 to the third is, well, 7 to the third is 343. 64 times 8, just not remembering. 512. So then we have two fractions with a common denominator, so we just take 512 minus 343, and that's 169 over 3. So what that means is, if I graphed this function and found the area under it from 0 to 1, that's how much area there is. All right, example 2 is the integral from negative pi to pi of the cosine of x over the square root of 4 plus 3 sine of x dx. So what should u be on this problem? Four plus 3 sine of x, right? Because that's being square rooted. So then you take the derivative of that. Derivative of 4 is 0. Carry down to 3. Derivative of sine is cosine. Then you divide. Dx is du over 3 cosine x. So then you translate. Integral cosine of x is still there. Then it would be over the square root of u. And then dx gets replaced by all of that. So du over 3 cosine x. Then that's nice because the cosines cross out. So we know we're on the right track. The cosines cross out, we have 1 over the square root of u. Also 1/3. And du. Last thing I have to translate is these numbers, right? So I'm going to plug negative pi into my u formula. Sine of negative pi. See, negative pi is going this way, right? All the way to here. So it's 0. 3 times 0 is 0. 4 plus 0 is 4. So when x is negative pi, this number is 4. Then when x is pi, sine of pi is 0 as well. 3 times 0 is 0. 4 plus 0 is 4. So what's the area under this function from 4 to 4 going to be? I don't even need to figure out the antiderivative to know that, right? I mean, on most problems, my next step would be take the antiderivative of this, and then plug 4 in and 4 in and subtract. But I know when I plug 4 in and 4 in and subtract, I'm going to get 0. But that makes me a little suspicious, because the original integral wasn't from pi to pi, right? It was negative pi to pi. So what do you think happens if we graph this function? Somehow the area is coming out to 0. So some of the area is positive and some of the area is below the x-axis, making it negative. And apparently the positive area is crossing out with the negative area and making a total area of 0. So that one was easy. We didn't even need to take the antiderivative. Again, most times at this stage we would take the antiderivative, but we didn't need to this time because it was 4 to 4. Okay, let's say we were going negative 4 to negative 5 underneath this function. So first of all, the way this is written throws people off sometimes, so I'm going to rewrite it. Negative 4 to negative 5 of 1 over t plus 3 dt. So what do you think u should be? Good, it should just be t plus 3. So then the derivative of t is 1. So du is just dt. So this is 1 over u du. Okay, then I got to translate negative 4, right? Negative 4 plus 3 is negative 1. Negative 5 plus 3 is negative 2. Okay, then what's the antiderivative of 1 over u? Natural log of the absolute value of u. Good. And we're going to figure that out from negative 1 to negative 2. So then you plug in negative 2 and plug in negative 1 and subtract. So this is the ln of the absolute value of negative 2 minus the ln of the absolute value of negative 1. That's the ln of 2 minus the ln of 1. Because the absolute value of negative 2 is 2, the absolute value of negative 1 is 1. Okay, now I want to remind you, there's a couple ways to look at this, but I want to remind you about a subtraction rule with logs. When you have two logs subtracted, you can combine them into one log, and you divide the numbers. So this is the same as the natural log of 2 divided by 1. Of course, 2 divided by 1 is 2. So then this is the same as the natural log of 2. Another way to think about it is, the natural log of 1 says e to what power? Natural log says e to what power, right? So this says e to what power is 1. E to what power is 1? The 0 power, so this is 0. So the natural log minus 0 is also natural log of 2. But I wanted to remind you about the dividing rule, because there might be a different problem where you have to know how to divide that out. So, yes?
How would you have switched the numbers, like, if you had done that, would that have affected?
I mean, it would have affected some of the steps, but I still would have gotten this as my final answer. Because then I would have had, if I switched them, I would have had to put a negative sign, right? So then it would have been negative ln of 1 minus ln of 2. So then I would have gotten negative ln of 2, which is ln of 2. Good. All right, next one has a trig identity in it, which I know you'll be excited about. Anytime there's trig, always glad of that, I know. So this is example 4. We got the integral of cosine to the 4th x minus sine to the 4th x dx. And then we're going to use cosine of 2x equals cosine squared minus sine squared. So here's what we're trying to figure out, and here's a fact that is going to help us, apparently. So for this one, we're not finding area, because it doesn't have any numbers on the integral, so it's an indefinite integral. We're just finding the antiderivative. So first thing we're going to do is we're going to factor this. So this is kind of a weird factoring, but it factors into cosine squared plus sine squared times cosine squared minus sine squared. Seems a little bit unbelievable, so let's just check that. So if I multiplied this out, I would take cosine squared times cosine squared. That's cosine to the 4th. Then I would take this times this. That would be negative cosine squared sine squared. Then this would be positive cosine squared sine squared. So the negative cosine squared sine squared would cross out with the positive sine squared. And then this would end up being negative sine to the 4th. So it works out. That's the difference of two squares, but you don't usually do it with cosine and sine, so that's a little bit tougher, but factors out like that. Okay, then what does this equal? 1. Cosine squared plus sine squared is 1. And then they told us that this is cosine 2x. So we have 1 times cosine 2x. Well, that's just cosine of 2x. So this really scary looking antiderivative with some factoring and an identity became this antiderivative, which is not quite as scary. Now this is sort of a U substitution problem, right? Why is it chain rule? Because 2x is inside cosine. But this is one that's easy enough that I don't think we need to write down all the U stuff. So let's just attempt it without writing that down. Antiderivative of cosine is sine. So this is pretty close to the right answer. Now, if we took the derivative of this, it would be the cosine of 2x, but then times 2. So we've got this extra 2 that we don't want. So if we put a half in front of this, now if we take the derivative of this, the half will carry down. The derivative of sine 2x is cosine 2x times 2, and the half and the 2 will go away, so we'll just get the derivative of this is just cosine 2x. And then, of course, don't forget plus c, right? Since it's an indefinite integral, we have to put the plus c. Everybody doing okay? So far the new thing is we're still doing U substitution. It's just we are finding area now. There's numbers on the integral. And because of that, we have to translate those numbers when we translate to U. If you're going to forget, if you're going to mess something up, that's what you're going to mess up. You're going to forget to change the numbers. So for example here, since it's negative pi to pi, you'll put negative pi to pi here accidentally, right? That'll be easy to do. So watch out for that. So now we're going to shift gears a little bit and look at this. What kind of an equation is this? Differential equation, because it has a derivative in it, right? And we're going to solve the differential equation. So what does that mean? Figure out the original y equation. We have the derivative equation. We need to know what y equals, what the original equation is. Now, if we did that, we would get a plus c. So we need a point that'll help us get rid of the c. So that's going to be given as well, 0.01. So now we're going to get a particular solution. Without this, we would have gotten a general solution. It would have had plus c in it. But now with this, we can get rid of the c, so we get a particular solution. Okay, now this is different than ones we've seen before. If this was a t, we'd be in business, right? Because then we could just take the antiderivative right from this stage to get the original y equation. But the y there changes things. We don't know how to take the antiderivative of y. So this is a brand new type of problem, a differential equation that has a y in it instead of just x's and t's. So we need a new technique on how to solve this. So what I'm going to do is I'm going to put the dt on the other side. And then divide the y over to here. So what happened was I put all the y's on the left and all the t's on the right. That's called separation of variables. So put all the y's on one side, put all the t's on the other side. So I got the variables separated. Okay, once you get to that point, then you can take the antiderivative of both sides. The antiderivative of y, 1 over y, is the natural log of the absolute value of y. What's the antiderivative of just 0.69? 0.69t, right? The antiderivative of 5 would be 5x. So antiderivative of 0.69 if the variable's t is 0.69t. Don't forget your plus c. Now people always ask, why did you put a plus c over here? And I'll say, fine, let's put a plus c over there too. So call that C1. So plus C1, right? And then this one, C2. But then couldn't I take that C1 and subtract it over here and combine it with that C2? Just subtract it over to here. So then that would be a third C. That's my C. C3. Everybody see? Why I don't have to write C's on both sides? Okay. Good. Totally good so far? So I got the variables separated, put all the y's on the left, all the t's on the right. Then I took the antiderivatives. Now I'm trying to find the original y equation. So I need to get y by itself. So now I have some algebra left to do. How do you get rid of natural log? I'm trying to get y by itself. That ln is in the way. So what do you do to get rid of natural log? You raise up both sides from e. So you do e to the power of both sides. So what I'm doing is I'm taking e to the left side and e to the right side. That's legal because I'm doing the same thing to both sides. The reason it's helpful is because then the e to the natural log crosses out, and I just get the absolute value of y. So this side is just absolute value of y, because that crosses out. Now I'm going to rewrite this a little bit, but before we talk about that, I need to review some exponent rules. Okay, so if you have x to the third times x to the second, what can you do? 3 plus 2, right? We would probably write x to the fifth, but it'd be fine to write x to the 3 plus 2 power. So now you could go backwards, right? If you have x to the 3 plus 2, you can split that up and write it as x to the third times x to the second. So that's my situation here. I have e to the something plus something. So I can split that up and write e to the 0.69t times e to the c. So it would be tempting to put a plus sign there, right? It's not accurate if you put a plus sign there. Watch out for that. Okay, then the last thing I have to do is get rid of the absolute value. So let's talk about that. if you have the absolute value of x equaling 7, what are the possibilities for x? X could be 7, or x could be negative 7, right? So here, that same thing. Y could be positive this, or y could be negative that. So y could be e to the positive, e to the 0.69 t times e to the c, or y could be negative e to the 0.69 t times e to the c. So I've got two possible answers here, and the 0, 1 is going to help me figure out which one is the right one. Okay, so now I'm going to plug 0 in for t, because I've got my initial value, right? So I know if I plug 0 in for t, I'm just putting a 0 in place of t, I know I'm supposed to get 1 out, because 0, 1 needs to be on this graph. 0.69 times 0 is 0. E to the 0 is 1. So I just have 1 times e to the c, which is just e to the c. So that's good. I know e to the c is 1. So I could solve for c, but I don't really need to. I could take the natural log of both sides at this stage if I wanted to, but I don't need to. Because now I know that all of this, e to the c, is 1. So I could just go back up here and replace what's circled by 1. So final answer here is y equals e to the 0.69 t times 1, but I don't really need to write the times 1. Okay, now let's try this. I know I'm supposed to get a 1 out if I stick a 0 in. This is 0 again. It's e to the 0 again. E to the 0 is 1 again, so that's negative 1. So I have 1 equals negative 1 times e to the c. Then divide both sides by negative 1. Now what does e represent? .71828. It's a number, right? Just like pi. Well, not just like pi, but it represents a number like pi represents a number. And the number goes on forever, but it's about 2.7. So we're taking 2.7 to a power and getting negative 1 here. If you take 2.7 to a positive power, it's going to be bigger than 2.7, right? If you take 2.7 to the 0 power, that'll give you 1. What happens if you take 2.7 to a negative power? That just means flip the fraction, right? It doesn't give you a negative number. It flips to 1 over something. So it's impossible to take 2.7 to a power and get negative 1. So that means this option is out. This is impossible. But it was important to write down both options. Because on a different problem, maybe this one's out and this one's in. All right, so I'm almost completely done. What I've got is y equals e to the 0.69 t. But I'd like to write this as a little bit nicer answer, because this is 2.7 and a 0.69 power. It's just a little bit messy. So one more exponent rule to remind you about. Let's say you have x to the third squared. What do you do in that situation? Multiply the exponents, right? So this is the same as the x to the 3 times 2 power. So you could go backwards. If you have x to the 3 times 2, you could write that as x to the 3rd squared. So here we have e to the 0.69t. So I'm going to rewrite that as e to the 0.69 to the t. Okay, so now, if you have your calculator handy, take e to the 0.69 power. So if you type things correctly, I think you get 1.995 or something like that. So when I chose this 0.69, I rounded it. I actually intended e to that power to be 2. But 1.995 is pretty darn close to 2. So let's just make it 2 for the purpose of discussion. Okay, so our final answer is y equals 2 to the t. Okay, now this is supposed to be the original equation for this information, right? For dy dt equals 0.69y and for the 0.01. First of all, does this go through the 0.01? 2 to the 0 is 1. Okay, so that's good. It matches up with that. Now how can I check to see if the derivative is correct? Take the derivative of this. So this is my final answer, but I'm just checking now. So checking, we're going to take the derivative of this, and this is a derivative that we don't see super often. So let's review. Let's say you had 7 to the x power. What is the derivative of 7 to the x power? Yeah.
It's the natural log of 7 times 7 to the x.
It's the natural log of 7 times 7 to the x. So if it's 58 to the x power, it's the natural log of 58 times 58 to the x. Came up once on homework, or maybe twice last week on homework, but we hadn't seen it for a long time, right? So what's the derivative of 2 to the t? It's 2 to the t times the natural log of 2. Okay, so now, with your calculator, type natural log of 2. It's about 0.69, right? What's the third decimal place? 3? What's after that? 5 or 1? Okay, so I could use 0.693 seventh period, and I might get a better, that would be closer to 2 then, right? Okay, so there's 0.69. And 2 to the t, what's that? It's y. So it is matching up with my differential equation that I started with, right? So we solved correctly. Any questions about any of that? So remember this was a tougher differential equation because there was a y over here, right? We're going to practice more of those in the next couple days, but that was why this was a tough problem. Thank you very much for listening.